a recording, so I'll do that. So welcome to chapter 3 of Deep Learning with Python. So for this chapter, since no one signed up to lead the discussion, I thought we just kind of do like a group discussion. I don't have any Quarto charts that I prepared, although I could have done like I did last week, which is I just let Claude create the entire thing, and it worked out pretty good. I was actually pleasantly surprised
Yeah,
how
I
good
thought it did too. I,
how
I watched
these
the video. I thought the slides looked good.
yeah, I changed like one thing on it. The only thing I changed, one of the tables didn't fit on a slide, so I just had to fix that. That was it,
Nice,
basically.
nice. I will definitely be using that trick going forward because creating the slides is like the biggest
Yeah.
burden to
And hey,
present things.
it's an AI book club, so seems fair.
Yeah.
Why not? So so did everybody get a chance to read the chapter?
Yeah, and maybe
Awesome.
like I don't have any great insights because I'm also new, completely new to deep learning, pretty new to Python, but it seemed pretty. I don't know, like I spent a lot of time going through the different frameworks. And I
Right.
feel like all I cared about was the end where it's like, you actually don't need to know any of that. You can just use Keras. That's the takeaway I have is like just use Keras. Maybe that's my statement. Now, let me know if I'm wrong. Did anyone come away with a different reading of the book?
I think I agree with you. I mean, the idea I thought was here's some different libraries that existed through history of time, like for 5 years, right? Or maybe it's been 10 years, but it's like very new stuff, newer than my house. And the idea was like, well, TensorFlow was created by, I guess, Google. That was the kind of the based on some other thing. I forgot what it was. And there was PyTorch, which was Facebook's reaction to that. And then Google said, oh yeah, I'll go one more and make something even better than TensorFlow and PyTorch, and that's JAX. So they outdid themselves with that. They claim it, I mean, it's better in some ways. Everything has their plus and minuses, I believe. Like PyTorch is heavily, and this is in the book too, right? PyTorch. I should tell you a little bit more about myself. Like I've done some of this before. I've used these libraries quite a bit before. Mostly PyTorch is the one I'm mostly familiar with because I did some graph machine learning a couple years back on some graph database, like some graph database, which is basically like instead of tabular data, now we've got these different rows are connected to other rows by links and stuff, right? So that's kind of how I like to think about it. And so to do that, you need to go another level of machine learning to figure out how to make those things know about each other at a very high level. So I guess the whole point of that was I've used Torch quite a bit. I haven't used the other ones very much at all. JAX is kind of new to me. I haven't used it much. I know it's used a lot in some of the newer Bayesian machine learning frameworks. So that's one of the reasons why I want to learn JAX. Like BlackJAX is one of them. It's like a really fast Bayesian inference, Bayesian sampling system. And I've just now been learning about this really cool thing called, well, you guys know about these image generating things like the stable diffusion and all that. Well, there's this newish library called Bayes Flow, which uses diffusion for sampling probability distributions, for doing what they call, um, what was the word for they called it? I can't remember now. I just saw this, like, this is new to me. I just saw this presentation on it. And anyway, it's really interesting. It basically uses the same kind of technology that's in stable diffusion. So it uses JAX. You can actually use Keras, but the JAX backend works way better for it for some reason. I don't know why. Um,
I mean, one of the things I thought or reflected upon when I was reading it was
yeah.
I I don't know why in my mind I thought these things had been around longer than they have. Like I'm
Yeah,
not so behind.
right?
I was like kind of ignoring it for a bit and then I was like, okay, it's time to get on this. Um, they're really not that old.
Yeah, what is this, like a third edition of this book too or something? I mean, it's like crazy.
Yeah.
These books are getting outdated by the time they get in print. But
Yeah. Yeah, I mean the field is moving quickly too.
yeah. So the point of that whole rambling thing was that now I'm trying to learn JAX because I can see these applications. I do a lot of Bayesian analysis. That's kind of my main tool for statistical analysis.
But when you say like learn JAX, what do you
Do
need to learn if you're using Keras, or are you like trying to do uh, lower level JAX interface stuff without using Keras?
That's actually a really good question because this library I'm talking about, base flow, it actually uses Keras. So, I mean, you just say backend equals whatever and try it, you
Yeah.
just change it. I tried, like, for example, I did try that on this one little tutorial notebook and like, it used JAX. So I ran the whole thing in JAX. I said, oh, let me just try changing it back into Torch. Everything ran, but it was just slower. It was turned out to be like
Okay.
three or four times slower. And I think that's because for that code, this ability, as the book talks about, right, JAX can do this just-in-time compilation, and it's really built to do that. And so everything gets compiled and down to C, I guess, and then it's much faster. Whereas Torch, it's like NumPy, every pieces of it are compiled, but you still have like at a high level the Python code going, hey, multiply these matrices. Well, the matrix multiplication itself is fast, that's in C, but then handling that matrix to the next thing or doing something else with it is back in Python level. I think is what I got out of that. So that's one of the reasons why JAX is faster for that. It's kind of cool. But PyTorch has the advantage that they said in the book, and that's something to keep in mind. That PyTorch is what's used for a lot of the deep learning, but a lot of the large language models, like on Hugging Face and things like that. So you'll use it there. But again, you don't actually have to know Torch. If you have, as long as you have the Hugging Face library installed, and you want to use a large language model, a local small large language model, it'll use Torch. You don't really have to worry about it necessarily.
Forgive me if these are basic questions. I have virtually no experience with neural networks or much of machine learning, but Hugging Face, a like distributor repository of pre-trained models
In a library as well, yeah, for handling
and
that.
a library and a Python library.
Right.
So like if you, Ron, were trying to do the MNIST data, like get a classifier for the MNIST data going, you could do whatever ReLU, softmax, neural network, mumbo jumbo you want to do. You could put that up, and then if I had other test new data coming in, I could just use your model, like pull it from Hugging Face, apply it to my new data. Like if I was getting like new numbers in handwritten every day, I could just use your pre-trained Hugging Face model to um, predict what the class of these handwritten digits is. Is that how Hugging Face works in practice?
Yeah, yes, in a sense. I mean, I
Okay.
don't think you have such small models as that, but for bigger models like, Llama, or text classification models, those are there and you can
Oh,
download them.
okay.
And
Okay.
they're in such a format that you can download the model and the weight, so they are pre-trained as well. So you get everything. You get the tensors and you get the model as well. The matrix multiplications essentially,
Yeah.
right? The structure,
Okay.
the mathematical structure of it.
Okay. And like I know I'm kind of deviating from what the book specifically talks about, but how is that different from
It
like
talks a little bit
Olama?
about it.
Like, yeah, it does talk about Hugging Face, but like if it's just a place where I could say like Olam, download the Llama model, like I've downloaded that from Olama. Is it just a different place, or do they serve different
Well, for example,
uses?
Olama works with Hugging Face. You can download Hugging Face models into Olama. Um, like you type in
Okay.
Olama HF, I think that's what you use, and you tell, hey, here's this model, and it will download it from there instead of from the Olama. Llama has their own,
Okay.
Olama has their own repo of models, but unless I'm
Yeah.
mistaken, I think you can download. I might be confusing that with Llama C++. It's another one of these local model running things. That one I know for sure you can download Hugging Face models. I think it came with Olama as well.
Okay.
But the
Okay.
difference is, I mean, I don't want to take up all the time in this, but it's actually really interesting, right? The difference is, like Olama, for example, is like for doing you want to run a model locally,
Yeah.
right? So you can, on Olama, you can pull a model, you can run the model, you can run a server for the model, so you can write a little Python script that talks to that model, just like you're talking to OpenAI, right?
Mhm.
That's that level of interaction. Some of those models could come from Hugging Face because it's a repo of models. But the other
Yeah.
level of interaction is Hugging Faces has a library. Now in Python script, you can now query and talk to the model more directly. And you actually have like the model there. So you can like put on another head on the model, like do
Okay.
some what do they call fine tuning of the model using Python. That's what Hugging Face does for you.
Okay.
So you go to
Okay.
like a
Cool.
deeper level with it. But so Hugging Face is two things. It's a library like for that. It's a really good library for that. They even have a good agent library too, if you care about that. But anyway, they've got a lot of cool stuff going on there. I like what they're doing.
Okay. Cool. I'll check it out.
But I guess the point of that was like in the book, they talk a lot about that's one of the advantages of PyTorch, but the advantage of JAX is like, oh, JAX is really good for doing other types of models where you really care about uh, doing things locally and doing things fast, you know. Not exactly. I don't know. I'd like to learn more about like why some models are faster with JAX than others, but that I think it has to do with the size of the model, maybe because like those very large models, like large language models, the matrices, like we learned, right? These all these models are built essentially off of a matrix multiplication and a right? A affine transformation called, but it's a matrix multiplication and some kind of nonlinear transformation on it, like a ReLU or whatever. And when that matrix gets really, really big, then you're dominated by being able to do that matrix multiplication fast. And that's when the GPU really makes a big difference. And PyTorch should be just as fast as anything else in that case. It's not dominated by CPU cycles, I guess. Yeah. So
Okay.
I guess you asked the question, like, why would you need, I think it's a good question. Like, why do you need to know about this, these different low level things? Well, I guess one reason is like what we just talked about is you like to be able to pick the right one. And maybe that's just a matter of trying different ones, but maybe you have some insight into which is the better one to use in your particular computer, your particular hardware. And then you get bad insights from that too. For example, like I was thinking, oh, the reason why I tried PyTorch instead of JAX is I was running this on my Mac. And I know JAX doesn't have any GPU support, metal, on the Macintosh, you have the metal shaders, whatever, MPS. And I know JAX isn't supported on Mac on the Apple Silicon anymore. And I know Torch is. Torch is really nicely supported, so I can run local models on my Mac, no problem, in their Torch run. So I said, oh, I'll just switch this to Torch. It'll be way faster. It turns out it was slower. And like, that was a mystery. I still don't know why exactly, but it's something to do with the fact that this type of model, these statistical models, this Bayesian sampling that was going on, doesn't really get the benefit of these large matrix multiplications, which kind of makes sense to me, but it was kind of interesting. So I guess what I'm trying to say there is my idea was, oh, I know a little bit about these backends. When I take advantage of it, it didn't actually work. So maybe, but it still would pay, I think, in the long run to know a little bit more what the different backends are for. And one thing they did talk about in the book is that if you do need to do some low level training, like you need to write your own training loop, which they said, I think we'll talk about again more later. But they did do a couple examples in that chapter about how to do training loops. And the point was that the training loop you do need to get you need to if you want to write the training loop, you'll have to work at the low end because each one of them has their own way of doing the gradients, right? The key point was each library, all these libraries have in common is the fact that they provide, I'm trying to do this from memory, what the chapter said, but maybe somebody can correct me. They provide what? They provide
An
A loss
API.
function optimizer, is that what you're thinking of?
right. So, but I mean, more at a higher level, that's good. That's another way to look at it too, though. Um, the most important thing these things provide is a way to compute gradients.
Right.
That's what these libraries really give you. And
The auto differentiation.
yeah, the auto
That's okay.
differentiation. And then the other
Okay.
thing was the ability to do tensor computations on the GPU and CPU, right? And there was some third thing, which I can't remember what it was now. There was a third thing. It has to always be three things, right? I have love two things. Three things.
It's
But
true. They do love three things.
Yeah, they come in threes.
what was it? Well, let me think. Maybe we can work this out. What's the most important
It's
thing?
funny. I'm looking at my notes and I only wrote down two things. So I'm sure there is a third, but it's probably not that important.
Yeah, it was like a stretch. We need a third thing.
Yeah.
Come on, give me a third thing. But
I'm
no.
cheating and I'm looking right now. It's saying a way to distribute computation
That's
across
right.
multiple devices. Yeah.
Actually, that's a good point because that's not a small thing. That's one of the things that, like, just a weird thing. Just remembered why these large language models started taking off is that distributed thing was key. Before that, like the dominant way of doing like sequence deep learning on sequences was something called recurrent neural networks, and they had the fundamental flaw that you couldn't really work them in parallel. You had to like work your way down the sequence. Whereas these transformer models can just like work on everything all at once, all in parallel. You can distribute it during training. So that was one of the key things. So it is important, even if I don't think it's as important. You can definitely do deep learning with just the other two even if you couldn't do the distributed. Right. Let's see what else was kind of interesting in that chapter. Anybody have anything else?
Um, I stumbled a little bit reading about like the gradient tape bit. Partially because those are all new terms to me. Like, I understand that gradient is like a slope, gradient descent. We covered it in
Yeah.
chapter 2. Like, what's the tape? Like, I'm imagining like Scotch tape or something. Like, is there a different
Like a
meaning to that?
recording, like a recording.
Oh, okay, like a
Yeah,
yeah,
yeah, like
okay,
a yeah
tape record.
tape record. Yeah,
Okay,
that's just how
gotcha.
TensorFlow does it. It like you put it in a context. You start in Python a context. One of these things you see that says with something. Whenever you see that, that's a context.
Okay,
And
yeah,
that means there's going to be some like background magic happening essentially while you're doing that. And the background magic in this case is it's going to be keeping track of every multiplication of tensor variables and everything else and building a graph so that later when you ask for the gradients, they'll know how to do it.
okay,
That's it, kind
okay,
of in a nutshell. It's actually not only that's a high level view and also as deep as I can go. As deep as I can remember anymore.
okay,
But
okay. Yeah,
yeah.
that the with, like I've seen it as like with something
Yeah.
open.
Yeah.
It kind of trips me up coming mostly from R. So I'll have to do some reading on that too.
Yeah, those are just definitely worth reading about those if you're new to Python because they're used a lot in Python, and the whole purpose of them is kind of to create a little well, one of the purposes is to create a little protective area of code. So when you enter that piece of code, it does a bunch of stuff. When you leave the piece of code, some other functions that are hooked in will automatically get called. So when you do the with open is what I thought of. When you do the with open, that means that when you get out of that context, the file will automatically be closed. You don't have to worry about any hanging
Okay,
unfleshed pipes or anything like that. So it's just kind of
and
meant
it
for that.
just automatically knows to like disconnect. You don't have to write that.
Yeah, you can make your own context things too. I mean, it's not the documentation tells you how. It's not
Okay,
hard. It's actually not that. It's less mysterious than it seems once you really look at how it works. But it's a cool little shorthand. You could do without that, but it's a shorthand for having to do it yourself. It makes it automatic, so you don't have to worry about to make sure that you finished
yeah, yeah,
context
okay,
and everything. But now people use it for everything like this. I know one of the libraries I use, PyMC for doing Bayesian analysis. It's a Python library for Bayesian data analysis uses that as well with the model context. It makes it really easy to write models. You just like say with, you know, PyMC model as blah, and you just like start writing statements that it interprets now as probability statements. It's pretty cool.
okay,
It's the
okay.
same kind of idea as this gradient tape thing. Looking through I just opened up the notebook. And have you guys tried running any of the code at all?
From the earlier chapter, yeah, but not from this chapter.
Madeline,
in
have you run
in
it?
Colab.
Yeah, in Colab.
So yeah, I ran it in Colab. I've also been trying to get my work machine to run it. Uh, like and get the environment all set up because ultimately like that's like my holy grail to like get it working on my work machine, but I am running into huge managed policy blockers basically, which I will have to follow up with IT on, I suppose. Yeah,
Oh, like you're trying to use Conda and it won't let you like go fetch the libraries and things or UV
it
or
won't even let me set a kernel.
Oh.
Like it's very, very locked down.
uh
So I'm gonna have to see if I can get special permissions to unlock it a bit. But yeah, it worked on Colab. Um, trying to get that same sort of setup uh working on an actual machine that has access to data, real
Is
data.
that because you're like in the healthcare industry, so they have a lot of
Yeah,
lockdown for what it called CUI, I guess that's military term, but
yeah.
same kind of idea, right?
Yeah, it's very locked down. And actually, and the organization that I work for is even more locked down than the average bear, I would say.
I always find that frustrating. I did a lot of work with a federally funded research development center for like, and we did contracts for Air Force and Department of Defense. And when we do stuff with them, a lot of things are on their systems, which are very locked down. It's like, well, how do you expect anyone to do any work? We need to write code on this thing. Can't even put a compiler on it. It's drive me crazy.
Yeah, it's sort of paradoxical to like
Yeah,
because they're like investing in hiring data science people, but then give them no infrastructure to
yeah.
actually do it. Um, so
Oh, you'll fight the battle and other people benefit too.
yeah, we'll get there. Usually I get there eventually after many emailings.
Yeah,
Yeah, but it seemed pretty flawless on Colab at least.
yeah. I mean, I've been running it on my computer I've been running on Colab by using Visual Studio Code and the extension. I think I posted something about it in Slack about how to do that. That's a really good way to do it because I can just work on it on my computer, but I'm actually using Colab's kernel in the back end. It's kind of cool.
Right. And I wouldn't be able to set that up on my managed machine, I'm
Right.
guessing. Like
Probably
I
not.
am doing it through VS Code, but I
If
doubt they're gonna
if you
let
can't select a kernel, then you're You're stuck. 'Cause that's
Yeah.
what you have to do.
Yeah.
But anyway, if you want, I could demo that if you guys want to see how that works. If you guys are interested in,
Sure.
Yeah, give it.
if I can remember how to do this. There we go. Share.
This is just on your personal machine.
Yeah. So here, I just shared my. Oops, I didn't.
That was sort of my plan B. Like if I absolutely could not get it working on my managed machine.
You should be able to see my whole window now. Let me just get
Hmm.
this thing out of the way. If I can grab it. There we go. Make this bigger. So this is Visual Studio Code. This is one of the notebooks. I just git cloned the whole directory into on my local computer, right? But rather than trying to run, uh, one of the things I found in my past experiences, you generally don't want to do you don't want to do a lot of deep learning, the actual deep learning you have to do when you have to actually do train models. You generally don't want to do that on your own hardware, right? You want to
Just because
do
it burns through it, or it's not
yeah,
powerful
your
enough.
GPU, even if you have a good enough GPU, you risk you have a consumer grade GPU, you risk like I did it like almost burn out my GPU on my PC one time 'cause been training these
Oh, dang.
graph neural
Okay.
networks and it got really hot, the fan started blowing. I'm like, uh-oh, and then the whole computer just shut down. And I'm like, well, I'm not doing that again. It came back to life, but it sure did scare me. So I started renting rent a GPU on the cloud seems to be the way to do these things. So so I'm doing that here just using Colab, which is cool because now there's an extension. Um, I have a lot of extensions. There's a Colab extension you can just install and it'll connect up to your Google account. And then once you've done that, if you, oops, where'd it go? If you open up your thing, there's actually a thing here. I don't know what that does, but you just select kernel and say, okay, give me, uh, actually there it is, Colab. Pick Colab and it'll connect. Okay, auto connect and pick Python. Okay, there's a few steps, but the idea is it just works.
Is
Now, go ahead.
Colab free, or does like the author of this book like pay for the server space?
I'm logging into my own Collab account. I don't have a paid account. Everything I'm using
Okay.
is the free servers. If you want to do like, if you want to do like your own training of big models, you're going to have to probably pay
Yeah,
for the use
pay.
to use the better
For
GPUs.
toy examples,
Yeah,
it's something
yeah,
covered by Google.
yeah.
And just to clarify then, like because, for example, for healthcare context, like I would never be allowed to train in the cloud out of prem because of privacy issues.
Correct. Yes. Yeah. So
Um,
you'll want to have local GPUs for that
yeah,
kind of thing for
yeah,
sure.
we
Or
have some, but they're yeah,
yeah,
poorly calibrated at the moment, I'd say.
yeah.
But good to know. Okay. But
Or take
right now,
advantage of pre-trained models that they're close. That's
yeah,
one of the nice things you can if you're whatever you're trying to do, there might be a pre-trained model that's kind of close, and you just have to do some small amount of fine-tuning on it to get it to work for what you want with your actual
yeah.
data.
So right now I'm in VS and I'm trying to like so right now you said you had to download the extension for Colab
Yeah, just install it. It's in the
and it's called
marketplace.
just
Colab.
Col
Yeah, if you hit the extension thing over here and you just
yeah.
start type in Colab, it should pull up.
Oh
Oops,
yeah.
not
Okay.
Colab. And then you just use
Okay.
this one. Yeah, there's some other ones out here. Okay.
Can't install it because it's not compatible with the current version of Visual Studio.
Oh, you need up. Yeah, you probably need to upgrade your Visual Studio
But of
Code, which
course,
is probably also locked down as well.
VS Code is also locked down.
Yeah, I feel you. I know how that is. But once
Uh,
I've done that, once I've connected, then I can just like run. I don't know, this always gives an error, but it's connecting to the Colab kernel right now. It will eventually return with the same errors every time. I'm not sure what this means, but it doesn't seem to have any impact. I don't even know if I have to run this, 'cause probably these things are already installed on Colab. But yeah, then after that, everything just kind of works. And I can now talking to Google Colab on my, even though I'm running the code on my desktop, I can talk to Colab. Hopefully it's not too slow today. Okay, well, anyway, there you go. And it works. Of course, you can install your own local kernels as well and use those. I probably do have an environment that's got this in it somewhere in one of these things. Maybe this one. Like I said, I don't think I installed Keras in this thing. I definitely didn't install TensorFlow. But yeah, it's just a matter of installing the things locally. If you install like JAX locally, like on a Mac, you won't get GPUs. Even if you install locally on your PC, on Windows PC, you will probably won't get GPUs. That's the CPU version, unless you go through some extra steps to make sure you get the CUDA version. But just stick with the CPU version for now because you can learn a lot from just not have to mess around with making sure all the rest of that things connect properly. I think. Yeah. Trying to find where they do the JAX version. PyTorch. I don't think I have Keras on here though.
Is there a reason you wouldn't?
This was for some other experiment I was
Yeah.
doing. There's no good reason not to. But this is now running on my computer. This is running the environment that I put on my computer for doing JAX experiments. That was all that was for. But anyway, it works either way. The nice thing about Colab is everything's all set up. You don't have to worry about, oh, why is that not there? I gotta go back in and put that in, whatever.
What kind of costs do you actually end up incurring for the collab? You said you kind of pay for it yourself.
No, like I said, I have my own account, but I've never paid him
You never
anything.
actually paid. Okay.
Yeah, I don't even have a credit card on there.
Yeah.
So
Yeah.
yeah. So for learning, this is ideal. For doing, like you said, doing when you actually start applying this, you're gonna, have to solve those problems when you get there.
Hmm.
But they're definitely solvable because I know a lot of people in these kind of industries are doing this stuff. So
Yeah. Well, it's like in some cases, like until I can clearly like articulate the problem and the
yeah,
barrier, like that is required before anybody's willing to lift a finger.
sure. Yeah.
So part of it is like you have to bang up against that, like to actually find the real problem to be able to articulate it, to sort of demand it in some ways.
Yeah, I get that for sure. Well, hopefully this book club will help you.
No, I mean actually like certainly already I've even just like the language, right? I'm not really IT speak language really. And I feel like I've gained more IT language in some ways.
Oops, I need that. There we go. Yeah, I mean, it doesn't hurt to. I mean, like they say, one of the best ways to learn something like this is just to jump in and start doing it. And otherwise you just get stuck in like what they call it tutorial hell, where you're just like, learn Python, easy way. There's like if you look for books like how to learn Python, there's like a million like intro Python books for like when you get past the intro part, it's like where do I get the real good stuff? You know, what I mean?
Yeah.
Not that really what you have to do is just start doing things. Find
So
a problem, start solving it. And
on that
nowadays, go ahead.
on that note, like is the book I haven't pre-read or anything, is it go into much more like PBL based sort of problem based solutioning versus like the first couple chapters are very like theoretical, laying the foundations kind of stuff.
You know what? I don't know.
Oh, you don't know either.
This is my first run through the book
Yeah.
as well. So your chapter is kind of the first one that actually starts doing something. So
Yeah.
um, it looks like I'm just skimming through it now. It looks like they got like a movie review thing.
Right.
So yeah, so it's kind of interesting. It's problem based, it looks like to me.
Yeah.
Predicting house
Well,
prices. There's simpler problems, but they have to be because you're just starting out. So
yeah. Certainly the whole time reading this chapter, I was like, all right, let's just like get to using these and see what's actually
I
what.
kind of I agree. I kind of had that feeling too. It's like we're
Same.
chapter three and we haven't done anything yet. We're just still
Yeah.
talking about introductory things. Let's get on
Yep.
with it already.
Yeah. Yeah. It's like nice to know, but really I will not internalize any of this until I'm actually doing it.
Yeah.
So,
Totally. What got me was it was the chapter opened by going through like the TensorFlow, PyTorch,
History.
JAX,
Yeah.
like what you can and can't assign because of like I
Oh,
guess like oh
right.
you can't assign it in the normal Python way. You have to use like a method of this class, and like all that seemed like implementation minutia. And I just wanted to like do something.
yeah. Yeah.
Yeah, I don't think there's any way you can internalize that from what they said in there. But maybe it's just meant to, expose you to it. So you're like, wait a minute, that sounds vaguely familiar. I remember there's some
Yeah,
issue with that.
I know where to come back to when it does matter.
Yeah.
One other question is the that I have is I'll just share my screen so you know what I'm talking about.
Yeah, go for it.
This graphic uh, right here that I will share right now.
Yeah.
CPU, GPU, TPU,
Yeah.
hardware. Uh, what are the differences? Like I understand conceptually central processing unit, graphic processing unit, tensor processing unit, but like, is it just a difference in speed and efficiency if I'm moving from, say, a CPU to a GPU to a TPU? Is it linear, like a TPU is always better than a GPU and is always better than a CPU? Or are there, like, if I had a sufficiently large enough CPU, could I do everything I can do on the same size GPU? Like, I know CPUs aren't as good, but I'm just trying to understand more of the differences between them, if that makes sense.
I think the answer is not always straightforward. Like a GPU, like I said in that sampling thing I was doing, I expected because I was moving the GPU it would be faster, but it wasn't because other factors mattered. And sometimes the GPU can actually be slower because it has to work, depending on what you're trying to do, it has to move things to the GPU memory, to the video memory, video RAM, and then back off the VRAM. So if you have small data sets, you're probably going to lose time doing that versus just doing the matrix multiplication on the CPU. So I think it's not
Okay.
linear, but it's not you can't just put a greater than sign in there on those two blue boxes
Okay.
because it's
Okay.
not true in general. But when you have large data sets, you're doing big multiplications, the GPU makes a huge difference. It's extremely, you basically find things you can't possibly train at all on a CPU because it would take weeks and you can do it in a few hours on a GPU type thing. So, and I don't know about
Okay.
TPUs. I've never used them, but the main difference with a TPU is a GPU is a TPU is the same kind of hardware. It's designed for doing fast matrix multiplications, except it specifically was designed for doing tensor multiplication. Whereas a GPU is really designed for multiplying matrices for video games, right?
Mhm.
That's what they
Yeah.
were. This is like so that's the big difference there.
Okay.
But the point was the GPUs were designed to optimize quickly doing matrix multiplications because that's what you need to do, you know, Fortnite or something on your
Yeah. Yeah.
computer. You couldn't possibly run Fortnite on a CPU, it just wouldn't work. It's too slow.
Okay. And I guess more seasoned professionals in this area have like intuition as to whether certain problems are likely to be most efficiently run on a CPU, a GPU. Um, I obviously do not have that intuition yet, but is there intuition to be earned through years of practice, or is it kind of every problem you just run a small set on each three and see which runs the best, or whatever you have access to?
I think you're really the answer. I think yes, but I mean I don't have that experience yet. I don't have reached that level myself by any
Okay,
means. Like I
okay,
said, I've used these things before, but I'm no expert by any means. But I do believe you. I think from my interactions with people who have used these a lot, they seem to have good intuition about these things. But a lot
okay,
of it is, what do you have access to? I mean, just all I have is this free GPU on Google Colab. Let me just try this thing, and that's not working. It's too slow. Well, maybe I get bigger GPUs or more of them or something. It's a lot of experimentation. Or rent a TPU
okay,
or 10. I don't know. All depends on the problem you're trying to solve. But initially, you start with small pieces of data on your CPU, understand how the problem works, then scale yourself up, right?
okay. Gotcha.
Yeah.
I mean, not to state the obvious, but I guess like the obvious one is like problems that can be converted into tiny little pieces and made parallelizable are the perfect fodder for GPUs. Some problems are not that easy to convert into that kind of small bite-sized piece, so you can't really parallelize them. Uh, there's limits to what can be broken up into pieces and run in parallel.
True. I mean, but one of the things about deep learning that's made it so successful is the fact that
It,
most of these can be broken
ex
up with this batch they call stochastic gradient descent, the batches. So you take, your gigantic data set of a million, billion, whatever it is, training samples, and you can just feed it small chunks at a time, and it works. Whereas
it,
you're right, some problems don't lend themselves to that.
yeah. I mean, to me, that is the crux of it,
Yeah.
like
Like,
of the deep learning, like of the success of this
yeah.
in
No,
recent
you're right.
times.
Yeah.
The fact that you can, there's now a sort of engineering way to break that down into those small pieces, because before that, really, at least for the average user, didn't really, or non like specialist user, that didn't, the tools for that didn't really exist readily.
And they don't really exist for example, you're doing like linear regression or whatever, like bread and butter GLMs, you can't break them up, right? It's not possible generally to like if you have a huge data
Yeah.
set and you
Yeah.
want to just do a regression on it, you're kind of stuck right now.
Yeah.
Actually, there are some newer technologies for this, but there is something called stochastic. I was just reading it the other day. It's kind of like a stochastic gradient descent, but used for a GLM. It's, it's kind of interesting. But yeah, you're right. There's not applicable universally. So this is the where the deep learning frameworks really have a benefit.
I mean, could you break up a little, just like if you were trying to do a regression, like logistic regression or some kind of, like, could you break up? I mean, that's essentially what it's doing, isn't it? Like you're breaking up all the pieces of the equation into like component little pieces and then putting it all together to come up with the solution. I mean, that's what it's doing, right?
Right, but like for example, in R, if you're doing
Yeah.
like a GLM, it's not designed to do that. You could do a GLM, I think. Certainly you can do a linear. You're going to do next chapter of this, but for
Yeah.
a regression, you certainly can do it.
Yeah.
But it becomes stochastic because you're only going to try to find the maximum likelihood estimator, for example,
Yes.
right?
Yeah.
And instead of just solving for the maximum likelihood estimate, like you might do in some linear things, we're going to use a gradient descent. And when you use a gradient descent on a subset of data, you don't get the right gradient, right? You get whatever the gradient is for that subset. So you go a little bit this way, then you get the next week, go a little bit this way. So that's why it's called stochastic, because you're like kind of rattling around. And after you do it enough, hopefully all the rattling around, to excuse my weird language, but will average out and you'll get close to the right answer. And that's kind of how this works.
And the R implementation would be just to do that all at once.
Yeah,
Yeah.
right.
Yeah.
For your data. But if your data set was too big, then you could try something like a stochastic gradient descent on a linear model for sure. And that's what, in fact, is like I said, it's going to happen in chapter 4, but using these deep learning frameworks to do it,
Right.
I think. Keep saying that, but I haven't read chapter 4.
Yeah, I guess I should read the chapter also. Yeah.
I'm wondering how neural networks split data across GPUs, like um, the third point earlier we said was that these
Well, I think
frameworks allow.
yes. I don't know what the framework does to help you with that, to tell you the truth. I suppose they have some tools for doing that, but they must, right? I don't, but conceptually, it's like Madeline just said, it's very straightforward, right? I've got all these batches. There's no reason why I have to wait for this GPU. I can put one batch on that GPU, one batch on that GPU, one batch on that GPU, and bring it all together.
Mhm.
So it's naturally parallelized. It's like what do they call it? Embarrassingly parallel, I think is the technical
Yeah,
term.
something like that.
They have no interaction at all, so it's super easy.
Um, so batch, if you have like a big tensor or just a tensor, the batch is like 1 to index 100. Like
Oh
I'm
no,
trying
well,
to
we're
build
talking
it.
about the data. So the other dimension, but
Okay.
the in terms of like the weights, the weights you couldn't. I don't think you can so trivially split those up and trying to. That depends on the structure of the model. Some models are structured in such a way you can, like large language models, a transform architecture has these like columns of things that happens to each input token, right? Has like a column that goes down. They talk to each other back and forth, but it's naturally parallelized, we can imagine inside the model. But I was just talking about parallelizing across data, which is more simpler. I
Okay.
don't know what the mechanics, so maybe I don't know if I'll talk about it, but I don't know how it's done in terms of that. I know it is done, but I don't know how it's done.
Gotcha. Gotcha. Okay.
It sounds like an advanced thing to me.
I will leave it alone for
Or
now,
maybe
I
it does
guess.
it automatically. I don't know. But
You
Maybe
sorry, good.
table that question, like write it down,
yeah,
see if by the end of the book you have an answer.
yeah,
Yeah, yeah.
good idea. Definitely.
Um, I'll say this because I'm involved in some other book clubs. Of late, at least, I'm not sure if this is a longer standing practice, but John seems to have been getting authors in for questions at the end of a
Yeah,
book club. I'm not sure. Honestly, I don't even know the authors' names. I know they invented Keras or something, but
yeah,
Chollet,
yeah. I don't know how to pronounce it
something like
either.
that. I don't know if they're if they'd be open to it. But we might be able to ask these questions to them.
Yeah, that's a good point.
Another question I had is the book makes a point that these are the big three frameworks: PyTorch, TensorFlow, JAX. For now, they might not always be.
Right. That's the beauty of Keras, right? Because whatever it is, you can
Yeah,
plug in. In fact, they mentioned
totally.
another fourth framework, MLX, which is Apple's latest foray. That's one of the reasons why Apple's not supporting JAX anymore. They decided to make their own called MLX for catering
Okay.
to the metal architecture. But
I guess I'm wondering in the future if another like if MLX or any other new framework comes along, on what like dimension is it going to be novel and different or better than the existing ones? Like, is it just going to be faster or like it's more like a pondering question. Like where's the field going to move in terms of frameworks?
good question. I mean, I don't know the answer to that. I mean, one thing I would like to see is more uncertainty quantification. Like all these
Okay.
frameworks are heavily invested, are all all gradient descent, and the idea is to try to find the maximum likelihood, even for where the weight should be. And there's no uncertainty quantification to it at all. Like they always just find the maximum likelihood. And as a Bayesian proponent myself, I like, oh, why can't we, do something to put some bounds on those parameters? Then we could do some kind of mixture model of all the different possible things. Might avoid overfitting, and maybe give you some idea how good your model is in its responses as well. Another way of understanding its responses. I'm kind of thinking out loud here. I'm not sure if this is totally logical or not, but it seems to me that we should be able to find some way. There are some ways, I know some clunky ways to do uncertainty quantification in these models, but there's something called Bayes by dropout. Um, for example, it just comes to mind. Dropout something we'll learn about later. It's a way of like regularizing the neural networks,
Okay.
keeping them from overfitting. It's basically what you do is you take your neural network and as it's training, you bang it across the head to make it forget things. That's the
Okay.
dropout part. You set a bunch of weights to zero. Say, now try it. Now memorize my data. That's how I think of it anyway. But yeah. But I don't know. That's one thing I like to see. I don't know what, I'm sure there's plenty of people thinking about new frameworks. I don't know what that would be. That's an interesting thing to think about.
Okay. Cool.
Well, also the comment that just base Python has won this round,
Oh, yeah.
like that didn't seem obvious that that would be true for me, and that maybe that won't not that it matters in the end because the framework could be written in something else, and if you're using a front end that basically hides a lot of it, maybe it's not even a big issue. But uh, do you think it's just timing that made Python quote win?
Absolutely. So, I mean, I've been using Python since it was like new. And what brought me to Python was essentially as a open source and well free free alternative to things like MATLAB and
Yeah,
Mathematica to some extent, but mostly MATLAB. There was something called Octave that was around for a while too. Around, I don't know if it's still around anymore. There's like another way of kind of getting a MATLAB type thing without MATLAB, but the idea of using a general purpose language like Python, but then when NumPy came out and these kind of things, it was really nice to be able to do these scientific modeling questions on my computer without having to worry about a MATLAB license and everything. They were kind of the first ones kind of jumped on that bandwagon, providing these kind of capabilities, and that seems like that's how it segued naturally into deep learning and all that, in my view.
it was like the tool that was there and free
Yeah,
and ready to use.
and people were already using it to
Yeah.
do stuff. And the other nice thing about Python was it has a really nice, clean, always has from day one interface to C. A really nice C interface because that's what it originally was. Like Python kind of was just meant to be like, oh, this is something I can put on top of my either embed in my C program for people to write scripts
Right.
for the C program, or I can call C from Python and get all the stuff I need. So it's was designed for that. And ours kind of has that too. It's just I don't know if people really use it as much.
Hmm.
Uh, it could have been R. I don't know, but R could have been that. But
I
R
wish it
lost
would be an
out.
R. No, I don't really wish it'd be an R. I mean, that would be very convenient for me, but um, uh,
It's
yeah,
another, yeah.
I didn't
It,
know for certain why it was the way it was.
I don't know for certainty. That's just my
Hmm.
guess, my the story I tell myself anyway when I think about
Hmm.
these things.
Hmm.
There is an opening for another language though because of this interpreted issue, right? Python's interpreted just like R is, and that's kind of a problem. That's why we have these things like just-in-time compilation and all that. And that does seem to be answering the mail though. But I still wonder, like, there's like I know there's something called Mojo or something. There's some other language. Julia is another one. There's some other languages that look like scripting languages, but actually do compilation naturally. Um, I don't know if that would get critical mass though, but you could see maybe another language moving in at some point. I think the thing is with Python 2 is that computers kept getting faster and faster. At first, when Python came out, it was really slow. You did everything in C. You used Python just to organize things.
Hmm.
But now,
That's how I think of Python, as mostly
yeah,
as an organizer.
yeah. But now because computers are so fast, you can write code in Python that's for some things it's just plenty fast enough. It's not fast, but it's plenty fast enough,
Hmm.
right? And I wonder too, like, I'm sorry, this is speculation, but I think out loud. These large language models all have these code execution tools now. Like if you ask like ChatGPT to like, oh, give me the 15th Fibonacci numbers, and it'll internally write a little Python script and calculate and then tell you what the answer was. So these things are all talking Python. So that gives more lock-in on Python in some ways. So that's
Yeah.
arguing the other way. Maybe we're stuck with Python. I don't know. Certainly worth learning it right now, that's for sure. For at least 10
Yeah.
years, I think. Another 10 years of Python is probably pretty clearly in the books.
Yeah.
So you're making a good investment in your time. That's what I'm
Well, I mean, of
trying
course, I
to
did
say.
try to like use TensorFlow from our studio for a
Yeah, that's
while, and I was
painful.
just like, ugh, this is killing me.
Yeah. I think
Yeah.
Okay,
TensorFlow from R uses Python as an intermediary
It
somewhere, doesn't
does. It does. Yeah.
it?
what was I've never used it in R or really at all, but what was like the frustration? Just bad documentation, slow,
W-
bugs.
Well, actually, I end up running into the exact same problem that I'm actually running into with group policy. Um, so that's the number one straight up problem, group policy. I still can't
Mhm.
access and set up Python how I need it. But also, I believe the packages that do the translating to TensorFlow are not updated as regularly. They're
Right.
not as
Right.
supported. So you're always sort of behind to like
Yeah,
whenever somebody decided to bring it into R.
gotcha.
You gotta get all the parts working. You get the TensorFlow part working, you gotta get the Python part working, you gotta get the R part working. It's like there's just too many parts, I think.
Yeah. Yeah. Enough that you're just like, okay, the slowdown in learning the Python, it's probably worth it just to go to it, to its native environment.
I thought R for Torch or Torch for R was didn't use Python in between, but I'm not sure. But just a
Right.
thought.
Maybe I only tried TensorFlow.
In my opinion, opinion, it seems like TensorFlow is the clunkiest of the three.
Is it?
I think because it's so big. I
Yeah.
did try using
It's
TensorFlow early on. Like that was the first one I tried learning, and I kind of gave up on it because there's so much to it. I mean,
right.
it does things in weird ways, and this tape thing, for example, it's like
Yeah.
just so I kind of switched over to Torch for that reason when I was trying to do my and also the um, a lot of the resources I was looking at, the papers I was looking at for doing deep learning on graphs was they were using Torch for everything. So I'm like, I'm gonna stop trying to translate everything. It's kind of the same problem. Stop trying to
Hmm.
translate everything, just move over to Torch. But
Yeah. Yeah. Is that like just TensorFlow's the maximally flexible one? Like it has the most potential for find defining your own everything.
they're all very flexible. I mean, JAX, they're all very flexible, I think. The
Hmm.
thing that the book makes a point that TensorFlow provides you is what they say it was like more deployment friendly. Like all the big deployments are done in TensorFlow. It's like more professional, maybe or something. I don't know why they said that, but
Right.
they suggested that that was the thing about the advantage of. They have these like lists in each chapter, like what, like the pros and cons of each one. And I
Right.
seem to remember that for TensorFlow, the pro was that it has a lot more infrastructure out there for deployment. That's
Ye-
what they said. I don't have any experience with that, but because it's kind of the oldest one too.
Yeah, because at the end, didn't he say like you could end up actually using all of them sort of in a project if you like develop in one and then deploy or predict
Right,
in
with
the other.
Keras, yeah, with
Hmm.
Keras, that was the idea that you could work on JAX on your computer, then like, oh, I got to deploy this to this cloud platform that uses TensorFlow. No problem. Backend equals TensorFlow, and
Right.
off we go. As long as you didn't do any custom training loops, and if you did, you'd have to translate those. And nowadays, you probably wouldn't even have to worry about it. You just say, hey, Claude or Copilot,
Right.
convert this training loop to TensorFlow,
Yeah.
and don't even bother telling me how it works.
Yeah. I assume it's pretty good at
Yeah,
doing that at this point.
yeah. And it's
Hmm.
only going to get better. It seems like every day these things keep changing.
Yeah, it's shockingly good at stuff that I'm even like, how
Yeah.
does it even know what these are?
Exactly.
Yeah, like our EHR system, it's pretty good at knowing how it's structured. I don't know how. I mean, obviously somebody's fed it.
Yeah. So it says TensorFlow is extremely feature complete. That's what they said. Has support for like ragged tensors. Has good data pre-processing. It says, and it says it's so good that even JAX recommends using the TensorFlow pre-processing library. So there you go.
Pre-process, like how, just from your own experience, like how would it compare to our like our studio pre-processing?
I have no idea.
Okay.
I don't know what TensorFlow data does, but I'm
Hmm.
just telling you this is what the book says. I don't know.
Yeah,
I would do my pre-processing using pandas or something and then move on from there. But I guess
right.
maybe I'm missing the boat because it should be or SciPy. SciPy has a lot of
Hmm.
pre-processing library, like doing or scikit-learn, I should say, has not SciPy. Scikit-learn has nice pre-processing things for doing things like uh, cross-validation splits and k-folds and all that kind of stuff. And I use that generally for that. But maybe I don't know what TF data does. Does it do that? I guess we'll learn. Maybe we won't
We're
learn
gonna
because
find out. Uh,
maybe we won't learn because that's not a Keras thing. But I think Keras has some things for doing that stuff too. Now that I think about it. Oh, I see. So it says I just looked up. It's like TF data build TensorFlow input. Again, it's like it's pipelining. What's that? There's an R library that's good at that. What's it called? I don't use R very much anymore. But there was an R
hmm.
library that's designed for like pipelines and designing your data flows and stuff.
Targets.
Is that it?
It's the one that comes to my mind, but
Yeah. So something like that does which again makes me think about the next point they make, which is about it being really good at for in production, right? The ecosystem for production deployment is the most mature among the frameworks. But the downside, it says it has a sprawling API and very inconsistent numerical API, which when you how they do the math. And I agree with that. That was my experience too. I'm like, wait, why am I have to do it this way?
Hmm.
So yeah, and then Torch it said Torch is awesome for debugging because everything's done eagerly,
Eager, yeah.
and that's my experience too. But that's also a downside because that means it can be slower. And they did say they had a compiling capability I've never used, and it even says here people don't people don't use it, right? So it's supposed to help speed it up. But I think that might be an answer to these other frameworks having a just-in-time compiler. I've never used the Torch compiler. And then JAX, the big thing there was JAX is fast, blazingly fast, because of the compilation. And this guy seems to like JAX because he recommends using it by default, even though the default for Keras is to use TensorFlow. Keras originally was only TensorFlow at one point.
Hmm.
They kind of went hand in hand.
What year was this version, third edition, published?
It just came out, like,
Okay.
I mean, pretty new.
I think it was like fall 2025 or
Yeah,
something like that.
Oh,
yeah,
okay.
yeah. What did it say about JAX? Here, I'm trying to.
I gotta hop off in two
Oh, yeah,
minutes
we're
for
almost
another
done.
call, but
Yeah, the only thing it says about JAX is the negative is the meta programming, the fact that you can't, it's all like functional. He calls it meta program, it's like functional. Like it's kind of like R like in that sense, but it's very functional programming style to work with JAX. You can't pass, you have to do things in a stateless way. You have to pass the state around. So that's kind of gets a little more difficult to use, but yeah. I don't know. Anyone else have any other things they want to highlight or comment on before we close out for the day? I think this was fun. I like doing this kind of discussion thing.
me too. Me too. I dare say I like it more than slides.
Yeah.
But
Yeah, much less work too.
yeah, yeah.
I mean,
You
it
don't
sort of
get
assumes you've read the chapter, I guess.
Right.
But I don't think the
totally.
intention of these is like really to like teach the chapter, correct?
No, and I keep falling into that because I'm just so used to doing this. I make these slides and I just started going through them. I'm trying to get away from doing that. Uh,
Yeah.
so this is a
Okay.
better. I think this is a better example of how to do it than what I did last week. So which is kind of like a lecture.
Okay.
Awesome.
Well,
I gotta hop
Maybe
off,
somewhere
but
in between. All right,
see,
guys.
see you next week.
See you next week.
see you next
Oh,
week.
I'll hit
Take
the
care,
end.
everyone.
Bye.
Bye.